Can you read back the discussion we just had about Vietnam, AWACS versus Starlink?
Sure, here's a quick recap of what we discussed. We started by talking about how during the Vietnam War, soldiers used portable radios like the ANPRC-25, which relied on high-altitude aircraft like the EC-130 ABCCC or the EC-121 Warning Star to relay their signals. These airborne relays helped overcome the challenges of jungle and mountainous terrain by extending communication range. We then compared this to modern-day Starlink technology, noting that while the concept is similar, using a high-altitude relay to overcome line-of-sight limitations, Starlink uses a network of satellites in low Earth orbit to provide global, autonomous, high-speed internet coverage. We imagine that if we had Starlink technology back in the 1970s, but without satellites, soldiers could, in theory, use a similar ground-based transmitter to connect to a receiver on an aircraft, essentially creating a Skylink network without the need for space-based infrastructure.
So what would the problem be with that?
One of the main challenges would be that the aircraft would need to maintain a stable and consistent connection with all ground-based terminals. Unlike satellites, which cover large areas from space, an aircraft would have a more limited coverage area and would need to stay airborne and in the right position for long periods, which could be logistically challenging. Additionally, the aircraft would still be vulnerable to weather conditions, mechanical issues, and even enemy threats in a conflict zone. So while the concept would definitely work, it would come with its own set of logistical and operational challenges.
What if we had those Starlink receivers on every commercial flight and we had them flying on military high-flying aircraft that flies above the weather, so weather wouldn't be a concern? Would that make a more consistent, usable network in theory?
Absolutely. If we had Starlink-style receivers on every commercial flight and on high-flying military aircraft, it would essentially create a robust, constantly moving network of airborne relay stations. This would definitely make the network more consistent and resilient because with so many aircraft in the sky at any given time, you'd have a dense mesh network, reducing dead zones and ensuring more reliable connectivity. Altitude advantage, high-altitude aircraft flying above the weather would indeed avoid weather-related disruptions, maintaining a stable signal. Mobility and redundancy, with multiple aircraft constantly in motion, the network would have built-in redundancy. If one aircraft had to leave the area or experience issues, another could seamlessly take over. Global reach, combining commercial and military flights, would provide near global coverage, creating a flexible, ever-present communication network. In theory, this would be a highly resilient and adaptable system, almost like having a moving constellation of satellites in the sky at all times.
Do these Starlink transmitters that are picking up the signal from the ground, do they need a strong power source to be able to transmit all the time?
Starlink terminals do need a consistent and reasonably strong power source. The phased array antenna technology that they use to track satellites and maintain a stable connection generally requires around 50 to 100 watts of power, depending on conditions and usage. It's not extremely high, but it does mean you need a reliable power source to keep them running continuously.
So airplanes would have that power source. Wouldn't you agree that having a Starlink receiver on an airplane that has a power source and could be serviced if needed in between flights would be a more robust, more reliable system than Starlink satellites falling around the Earth in outer space?
In many ways, yes. Having Starlink receivers on airplanes could create a very robust and reliable network. Airplanes already have consistent power sources and can be maintained and serviced regularly on the ground, which could reduce downtime and technical issues. Plus, having a network of high-flying aircraft could offer some flexibility and redundancy, making it a strong alternative or complement to satellites. Of course, satellites have their own advantages in terms of global coverage and reaching remote areas, but a hybrid approach that uses both aircraft and satellites to be really powerful.
Okay, that's it.
Got it. If you ever want to dive into more tech ideas or anything else, just let me know. It was fun chatting about this.
The Flat Earth Clock app has a new feature that will be a game changer. Flat Earth proof flashcards are here. Over 200 proofs destroying the globe. Swipe to go to the next card or click the shuffle icon to go to a random card. If you see an info icon on the top, click it to get more information on that specific flat Earth proof. Click the back button to go back to a previous card at any time. The more info icon could be a website, a playlist, a book, or a video. Use the share icon to share cards with others via text, email, airdrop, or any other sharing modality. Update your Flat Earth Clock app today and start increasing your Flat Earth knowledge and sharing it with others.